Morning all. I welcome you all for next lecture series. In this series, we are going to discuss about structure of power system. So I think we all remember for the last lecture, we are discussed about the introduction of power system. So what is power system? What are the sources we are using? And what are the generation classification? Under the classification, what are the sources we are using? And how the one form of energy is converted into another form of energy. We can say it is the solar energy is converted, the heat is converted into electrical energy. For the wind power, kinetic energy is converted into electrical energy. For the hydrothermal, this the potential energy is converted into electrical energy. As all those things we are discussed in the last lecture. So for the continuation of the introduction of the power system, today we are going to see the structure of power system. So structure of power system, it is a, I think we are discussed, power system is a network which consists of generation and then transmission and also the distribution. These three areas are connected through the supporting towers, and the powers are distributed from generation area to the distributors, that is industries, and for the householders. So, or for the consumers. So, how it is converted from the generated power station to the distribution system. Let's see. So, here I also shown the picture of power system. See the power plant here. There is a power plant is available. From the power plant, there is a possibilities of kV is produced more or less 11 kV or 33 kV. These 3 kVs are only produced from the power plant, and which is not sufficient to transmit. So because of the losses, so we need a more value of kV to transmit from one area to another area. For the purpose, here we are step up the voltage through the transformer. So here 11 kV is produced from the power plant, and it is converted into 130 to 220 or 440 kV. So these three kVs are transmitted through the transmission lines, and again it is step down the voltages based on the needed of the requirements for the substations. So again we are step down the voltage through the transformer, that is a 66 kV, and then the 66 kV is transmitted to the consumers. Again, the consumers needed only 11 kV. For example, industries are needed only 11 kV. And for our end users, that is, we are all using only 220 volts or the 240 volts normally in the industries, and 11 kV also used by the industries. So for the purpose, again, we are step down the voltage, that is 66 kV is again step down through the transformer to 11 kV and then 33 kV. The 11 kV is used for the industries only, and again the 33 kV or 11 kV is transmitted through the transmission line, and here there is a step down transformer for the purpose, that is for the household we are using only 230 volt. So based on that, we are step down the voltage from 11 kV or 33 kV to 230 volt. So here itself we are heard the word kV, 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 and here only we are heard the word that is 230 volt. So 230 volt is stepped down and transmitted to the poles to the consumers. So this is how we are using the power from the power plant to through the transmission. How we are step down and step up for the needed. We are using the voltage, and finally we are distributed the voltage to the end users. So I think you all know very well about the structure of power system. And for structure of power system consists of the components are transformer, transmission line, substation, distribution line, and the distribution transformer. I think here we are using the transmission line, substations, and the distribution systems. That's why we are called as the main component of the power system. And the power system normally through the that is for the needed we are a step up or a step down the voltage through, and we are transmitted the transmit the voltage through the transmission line, and wherever we need we are step down or step up for the suitable value of consumers. This is how we are seeing the structure of our system. This is also we are called as the structure of our system, and further it is called as the single line diagram. So that we are shown in this type of system we are called as the naturally how we are transferring the power from the generation area to the poles or towers are we are here, and the transformers also we are showed here. But this diagram we are called, considered as the structure of our system is in the form of single line diagram, which consists of primary transmission line and secondary transmission line, and primary distribution and then secondary distribution. So primary transmission line consists of 230 volt to 33 kV, and the secondary transmission lines consisting of 33 kV and 6.6 kV. Again, the primary distributions considered as the large bulk loads under factories industries. For that, we are reduced through the step down transformer. For the distribution also, we are using step down transformer. That is, we are using 400 volts and then 230 volts. And finally, we are reaching the end users to the consumers, service mains, and then secondary distribution systems. This we call as the distribution system. So I think you all know very well about I think you understand about the structure of our system. So again, I'll mention here you are using step up transformer, here the step down transformer. Again, we are a step down on the distribution transformer also step down. So from the generation area only, we are using the transformer as a step up. Again, wherever we need we are using only step down transformer. So see you in the next class. Thank you all.